Good morning. In today's session, we will learn about forced oscillations. In the last class, we have learned about damped oscillations. Now, we are going to learn about forced oscillations. Okay, this is also a probable essay from this chapter. Just like damped oscillation, they will ask you to derive the expression for forced oscillations like that. So, the procedure is the same. There is only a slight difference in the main equation. Okay, once you learn damped oscillation, then it will be very easy for you to follow forced oscillations. Okay, so let us begin. An external driving force can be used to sustain oscillations in a damped oscillator. The damping or the resistive forces are still there, by that will try to retard the oscillation, but the applied force will try to maintain it. Finally, the oscillator starts vibrating with the frequency of the external source. These oscillations are called forced oscillations, and the oscillator is called a forced or driven harmonic oscillator. Okay, I will brief the meaning. In the last class, we have learned about damped oscillation. That is, suppose that you have an oscillator and it is you have displaced it from its equilibrium position. That means it is you are making it to oscillate. So definitely it will be in the presence of some dissipative forces. So because of this dissipative forces, what happens? Gradually the energy of the oscillator decreases. As a result, amplitude of oscillation decreases, and finally as time progresses, oscillation will come to a stop. Okay, that was damped oscillation. Now, if you want to maintain oscillation, that is once oscillations stops, if you want to maintain the oscillation, what you do? You will apply an external force. Once you apply the external force, then the oscillation which was stopped earlier will now continue. Okay, that is oscillation will begin, or we can say the oscillator will continue to execute oscillation but with a frequency of the external source. Okay, that is when the oscillation stops, if you apply an external force, what happens? The oscillator will continue to maintain its oscillation with the frequency of the externally applied force. So such oscillations that oscillate or such oscillator that oscillate with the frequency of the applied external force are called forced oscillator or driven harmonic oscillator, and the oscillations with the frequency equal to the frequency of external force is called forced oscillations. Okay, I hope the meaning is clear. Now, just like the case of damped oscillator, various forces acts on forced oscillator also. One is the restoring force, which we have already discussed in the last class, given by minus kx, where k is a force constant. The next one is a damping force, that also we have discussed in the last class. It is given by minus gamma dx by dt, where gamma is a damping coefficient. Now here, in the case of forced oscillator, one more additional term comes. What is it? It is the external driving force, represented as F equal to F0 sin pt, where F0 is the amplitude and P is the angular frequency of the driving force. Okay, in the case of damped oscillator, there were only the first two terms, but in the case of forced oscillator, you have a third term also, that is the external driving force. Okay, so using all this, you can write the equation of motion for a forced harmonic oscillator. Can you write? This is mass into acceleration, that is force. Now this is the damping force, minus kx is the restoring force, damping force, externally applied force. All these things are written. Now what you do next? You will divide LHS and RHS with M mass. You are dividing it, so you will get this equation, and finally you are making some replacement, that is you replace gamma by M with 2c, and you replace k by m with omega 0 square, and finally f0 by m with the small f0. Okay, then you will get equation 43. These are the replacements or substitutions that you make. Now equation 43 is a linear non-homogeneous differential equation, and its solution will be a sum of two terms. One is will be a complementary function and the other one a particular function. The complementary function corresponds to solution of homogeneous part. Okay, and here our aim is to find the particular function corresponding to non-homogeneous part. There is no need of mentioning that paragraph. It is sufficient, well sufficient that you write up to this much. Okay, no need of mentioning this. Then after writing this, write up to this, then after that you just write the sentence. To obtain particular function, we have to assume a solution of the form x equal to a sine pt minus theta. So write this slide completely. Then from this slide you write up to this much. No need of writing this paragraph. Then after that straight away go to this one, that is to obtain particular function, you just assume a solution of the form x equal to a sine pt minus theta, where a is the amplitude of oscillator, theta is the phase difference between driving force means the externally applied force, and the displacement of oscillator. Now you just differentiate equation 44. So LHS x becomes dx by dt. What about RHS? A is a constant, it is written as such. What is the differential of sine pt minus theta? It is cos pt minus theta into p. Okay, this will give you this equation. Once again you differentiate. So dx by dt will become d square x by dt square, and this session will become minus ap square sine pt minus theta, because differential of cos pt minus theta is minus sine pt minus theta into p. So that will become minus ap square sine pt minus theta. Now you just substitute the values of x, this one dx by dt and d square x by dt square. These values you just substitute in equation 43. Okay, that is in place of x you are going to write a sine pt minus theta. In place of dx by dt you are going to write this, and in place of d square x by dt square you are writing this. So your equation 43 will now reduce to this. Okay, this is just substitution, nothing is confusing. And now next step is you are just grouping the terms, that is here you have sine pt minus theta, here also you have sine pt minus theta. So just group those terms, so you will get like this. Now you have cos pt minus theta, that is written as such. This is equal to, what about your RHS, f0 sine pt? You are just rewriting it as f0 sine pt minus theta plus theta. It is just the same as f0 sine pt, right? Okay, why you have written it like this? Just to bring it in a particular form. See, f0 sine pt minus theta plus theta is written like this. Do you know how you got it? Here they have taken sine pt minus theta plus theta as sine a plus b, where a is pt minus theta and b is theta. What is the expansion of sine a plus b? Sine a cos b plus cos a sine b, and then you just multiply each of this term with the f0. So you will get this equation. So you have got your LHS and RHS. Now what you do? You just equate the coefficient of sine pt minus theta and cos pt minus theta on both sides. On equating, you will get equation 45, 46. Right? Now just square and add equation 45 and 46. This will give you, that is a omega 0 square minus p square. You are just squaring it and adding. Then what about RHS? With RHS will become f0 square sine square theta plus cos square theta, that is 1. So you will get your RHS as f0 square. So you just write each of this step by step in a paper, then only you will be able to understand. So once you equated the coefficients of sine pt minus theta and cos pt minus theta on both sides, you will get equation 45 and 46. Just square and add equations 45 and 46. You will get this equation. Okay, now here a square is common, take it outside, you will get like this. Now from here, from this equation you can write a as this. Okay, that is your equation 47. Now you substitute the value of a in 44. What was your equation 44? X equal to a sine pt minus theta. Now you got the value of a. What was a? Amplitude of oscillator. Okay, so on substituting, your equation 44 will become like this, equation 48. Okay, so that equation 48 is the particular function of the non-homogeneous part of equation 43. Okay, so the total solution will be the sum of two functions, that is equation 41 and equation 48. So the total solution is given by x equal to a0 e raised to minus ct sin omega t plus 5 plus a sin pt minus theta. So here, after writing this, you just write the sentence, the total solution of the function is given by this one, and mark it as and give it an equation number. Okay, now here the first term on the RHS, that is this term on the RHS, represents what? Damped oscillation of frequency omega with its amplitude decaying exponentially to 0. Okay, here you can see an exponential part. So this term represents damped oscillation of frequency omega with the amplitude decaying exponentially to 0. Now second term, this term corresponds to driven oscillation of frequency having constant amplitude A, because there is no exponential part. So you are having a constant amplitude A in this case. Okay, now the former term will decrease quickly, whereas the later one will remain. Okay, that is, since this term decays exponentially with the time, so it will go off easily, but this here amplitude is a constant, so that will remain. So that paragraph, this paragraph you have to write. Then to obtain the value of theta, what you do, you have to just divide equation 46 by equation 45. Okay, then that will give you here equation 45 by 46. Okay, that will give you f0 sin theta by f0 cos theta, that will be tan theta equal to 2 cp by omega 0 square minus p square. So theta will be tan inverse of that. Okay, so that's all about forced oscillations. If you want to understand this, you must first read through the case of damped oscillation. Okay, then only you learn forced oscillation, because the procedure that is followed here is the same as that followed in the case of damped oscillation. Okay, so study damped oscillation first, and then you come to forced oscillation. These two are probable essay questions from this chapter. So once again I will tell how to write this slide completely, then this one up to this, then straight away start with to obtain particular solution. So the slide completely, this one also completely, and here once you get substitute the value of x here after writing equation this one, straight away write the total solution of is given by this one, then write the rest, the paragraph, and finally up to this much. Okay, so just go through damped oscillation first and then study forced oscillation, then it will be very easy. Okay, so that is enough for today. Thank you.